Welcome children to our next class of mathematics. I, Ruby Sharma, will be taking up your common multiples and LCM today. So already we know what are multiples. So get the definition of multiples, how to find the multiples. So today we'll be doing common multiples. Now directly we come to the question. Find first two common multiples. Now if they tell you find common multiples, you can find out any multiples of numbers and then find any two common multiples. Now what do you understand by common? Common means it has to be present in all the numbers. Isn't it? So sometimes we do speak about common. What is common between the two? Isn't it? Or what is common between the animals? Or what is common between the two persons? So it should be same. Now when we say find first two common multiples of 4, 6 and 8, we should first find the multiples of 4, multiples of 6 and multiples of 8, and then we find the common multiples. Now when there are three numbers, we have to keep in mind that the common multiple should be present in all the three. When there are two numbers, the common multiple should be present in all the two. Okay, so let's start with the first one. Now here I would like to give you a hint. Now when it is 4, 6 and 8, it is always preferable to write the greater number first. Find the multiples of the greater number first. Like multiples of 8, then 6, then 4. Why I am telling you? Because the multiples of 8, you'll have to find less numbers. For multiples of 6, it will increase a little bit. For the smaller number, multiples of 4, you have to find a lot of multiples to get a common one. So now what do? We find the multiples of 8. And if you observe here, you see I've left spaces here. Because if I don't get the common multiple, I have to continue with the multiples. Now here multiples of 6 also have left space. Multiples of 4 also here, like you don't have to leave space in the last one, the smallest number. Because from here we will decide whether we are getting common or not. So now multiples of 8 are all these. Multiples of 6 are these, and multiples of 4 are these. Now when we see, what do we observe here? We see 24 is the first multiple that is common in all the three. Isn't it? Of course 16 is present here also, but it is not present in the multiples of 6. So that cannot be a common multiple. Is it clear? So it has to be present in all the numbers that are given. So 24, then the next common multiple, again you check it out, it is 48. So this is one of the ways how you can find out two common multiples or three common multiples and so on. But there's another way. When you get the first common multiple, the rest becomes easy for you. I'll show you that method also. Suppose 13 and 39. Now the multiples of 39 are all these. Multiples of 13 are these. I have left space because if we need, say suppose we are not getting the first common multiple, we need to continue, isn't it, with the multiples till we get a common. So now here we already got 39 as the common multiple. Now instead of continuing like this, another way is when you get the first common multiple, say 39, the second common multiple will be multiplying by 2. Okay, and the third common multiple will be 39 into 3. So when you get the first common multiple, the second common multiple, third common multiple, you can find by multiplying by 2, by multiplying by 3, okay, and so on. So I hope that's clear with you. Then you have to write the answer of the two common multiples are 39 and 78. Now we come to LCM, an important thing. Now LCM by prime factorization. We will learn two methods today itself. because prime factorization you have been doing for quite some time. So prime factorization I won't explain. 24 and 90, this is how you prime factorize and you write it like this. But LCM is different from HCF, so don't confuse it, children, and it will need practice. You have to do with practice with HCF also, practice with LCM also to understand better. So just listen to the explanation how you find the LCM. The best method is, first of all, after you prime factorize and write it in this way, you see what are the numbers present here. So the numbers, the prime factors, they are all prime factors. If you observe it, prime factorization, you have only prime factors. So 2, 3, and 5. So what do you write here? Separately, you just keep a note, keep a track of the prime factors that is present here. So here it's 2, 3, and 5. So you write 2, 3, and 5. Now you see 2 is present in the highest number in which part? Now in this, here it is 3 times and here it is only once. So you highlight this. You can circle it, you can highlight it, whatever you want, you color it. Next is 3. Now 3 is present here once and here it is 2. So the maximum number of times it is present should be highlighted. And the next is 5. Now 5 is present only here, so highlight that. So one thing you have to observe is first you write all the factors, prime factors that is involved here. Then find the maximum number of times it appears. Okay, and you color it or you shade it or whatever you want. Now that shaded part or the colored part or the highlighted part is the, you multiply it and you get the LCM. So 2 into 2 into 2, this is 3 times, then into 3 into 3 into 5. Now how you multiply, you have to do your calculation. 2 to the 4, 4 to the 8. 8, 9s are 72. So whatever you mean, then 72 into 5, you do it here and you write the answer. So just don't miss out any numbers. See that you multiply correctly. Okay, is it clear all of you? Next, we'll come to another sum with the same method. 40, 48 and 45. Okay. Now these are 3 numbers. I've done the prime factorization also, which you have already learned. Now see, the prime factorizations of 40 are what? 48 and 45, you write it like this. Then what are you supposed to do? You write what are the prime factors involved here. Here also it's 2, 3 and 5. So 2, 3 and 5 is written here. That is, you have noted down to the prime factors. Now you have to find in which line, in which number 2 appears maximum number of times, 3 appears maximum number of times, and 5 appears maximum number of times. In this way, actually, it becomes easier. You just have to remember the steps. So here 2 is maximum here. So highlight it. Here it is 3 times, here it is 4 times. So you highlight this. Then 3 is maximum here, 2 times. Here it is 1 time, here it is 2 times. So you highlight this. Here there is no 3, so you don't have to worry about that. Now 5 is present here once and once here. So it is same. So any one you highlight. Okay. So every line will have that you cannot highlight in both the case. You have to take only one line. So since 5 is highlighted here, you don't highlight it here. So what is the method? The prime factor 2 appears maximum number of 4 times in the prime factorization of 48. The prime factor 3 occurs maximum number of 2 times in the prime factorization of 45. So I hope you are following this. And the prime factor 5 appears 1 time in the prime factorization of 40 and 45. But we take it only once. So what is your LCM? The product of the highlighted parts. And that you do the calculation in the rough and it comes to 720. So this is how you find out by prime factorization. So if you remember the steps, children, it will not be a problem. In HCF, we had taken differently. We had taken only the common ones. In LCM, we have to involve all the factors, prime factors. And every prime factor, we have to see in which prime factorization it appears maximum number of times. And then you follow the steps. So try to do these sums. Now next is find the LCM of 20, 25 and 30. Okay. So we have come to the last sum. Find the LCM of 20, 25 and 30, but this is the division method. So now this is another method, 20, 25 and 30. Now this is similar to prime factorization only, but it is all done together. So we say division method. Now what is the first step? Divide by the least prime number which divides at least one of the given number. So first we have to check all these numbers and see which is the least prime number it will be divisible by. So 20 and 30 will be divisible by 2. Though 25 is not divisible by 2, but the rest other two, even if one number is divisible by 2 here, we will write 2. Right? It's like 2 tens are 20. The prime factorization method only we are doing. And since 25 is not divisible by 2, we bring down as it is. And then 2 15s are 30. So this is the first step. Now here also see in this 10 is divisible by 2. So again we write 2. Even if one number is divisible by 2, we have to divide by 2. So we write here 2, 2 5s are 10. And all this we just write as it is. Okay. Now here none of the numbers are divisible by 2. So we cannot take 2 here. The next number is 3. Because 15 will be divisible by 3. Are you observing here? I hope you have understood. So we write here 3. Now this 5 we will bring down as it is. 25 also we will bring down as it is. So 3 5s are 15. Okay. Now this line. There is no number that is divisible by 3. It will not be divisible by 2 because it has already finished here. 10 was the last number. Now there is no number which is divisible by 2 and by 3. So next prime number is 5. So we write here 5. So 5 ones are 5, 5 5s are 25. We see each number is divisible by 5. 5 ones are 5. Now till we get all 1, like in prime factorization, we continue. So here the next number is only 5. And 5 is a prime number. The last prime number to be divided is 5. So 5 ones are 5, 5 ones are 5. Okay. So these are the prime factors whose product will give you the LCM. So when you multiply 2 into 2 into 3 into 5 into 5, you will get the LCM. And what is the LCM in this case? You will multiply in the rough, but still I'll tell you, orally you can do commutative property. If you remember, 5 2s are 10, 5 2s are 10, 10 10s is 100, 100 into 3 is 300. Or you can say 5 5s are 25, 25, and then this 4, 100, 100 into 3 is 300. So you have to write is equal to 300. Is it clear? So I would like to request all of you to do this sum both by division method. I have already done it. You just copy it down And then you do by prime factorization method and see if you arrive at the same answer. And the two sums that I did, find the LCM of 24 and 19 and 40, 48 and 45, you do by prime factorization method. So that means there are three sums of LCM that I've done today, isn't it? The three sums you will these three sums you will do both by the division method and by the prime factorization method. So you write find the LCM, then you do the first one by prime factorization method, do the first one, the second one, and this example. After finishing these three sums, you write find the LCM by the division method. And then again you write 40, 24, number A, 24 and 90, number B, 40, 48 and 45, and number C this. So the three sums you will do once by prime factorization method and once by division method, okay? So I hope it's clear to you. Till then, be safe. Bye-bye.